In this exercise, we're going to look at two ways of traversing a binary search tree. One way is called in order, and the other way is called pre-order. There's actually a third way, post-order, but I'm going to leave that out because it's not all that useful, and you can figure out how to do it very simply after you see how to do pre-order and post-order. We're going to recreate the binary search tree you see in the diagram in front of you after we've written the methods for binary search tree traversal. Then we'll use those two methods to generate a list of the nodes in the tree. So let's get started. We're going to go back to our binary search tree class. Here's the class again. And now we're going to create the two methods. The first one will be the in order method. And all this first method does is present a public interface to call a private method by the same name with the root as its argument. So here's the private version. So in order is a recursive method that checks them first to see that the root node, which will be the original parameter or the original argument, is not null. If it is, then you move to the left. Then once you've moved as far left as you can, display data at that node. Continue moving left. And then when you're finished moving left, then you start moving right. And this probably looks too simple, but as any good method should be, it's just simple enough, and you'll see how it works here in just a moment. Now let's go ahead and write the pre-order method. It also calls a private method of the same name with the root node as its argument. Its definition looks very similar to in order. The only difference is we write out the data in the nodes first as we come across them, and then move to the left, and then move to the right, like so. So let's save the program, and then compile it. Okay. Now let's look at our program to test. So here we have our old B-tree program that we used in the lessons. Let's start over again. I'll just leave these in place and just change their data. And we're going to create several nodes here. So we'll do a little cutting and pasting, just making sure that we change the argument for each insert. And here's our last one. Let's do in order first. All right, so let's see what we get. Remember the order, 8, 7, 13, 3, 10, 6, 4, 1, 14 is the way we put them into the binary search tree. Now let's watch what in order does to display them. Clear the screen. In order, 1, 3, 4, 6, 7, 8, 10, 13, 14. So again, let's look at the in order method. Move to the left, go as far as you can, then display, then start over again, keep moving to the left, and then when you're done moving to the left, move to the right. So now let's try pre-order. We'll just comment out in order. Save the program. Clear the screen. Compile. And then run. Notice how everything below 8 is here, everything above 8, 8 being the first item we entered, which will be the root, is below. And that's how pre-order works. So the other traversal method is called post-order, and I won't implement that. It's very simple to do. Simply do post-order in.left, post-order in.right, and then display the data. And that'll show you how the binary search tree data is traversed in post-order. What I'd like to do now is move to the final exercise, where I'll show you how to write minimum and maximum methods for a binary search tree.